SA node is the primary pacemaker of the heart, right? It's the site where cells depolarize most rapidly, and therefore it's the site where the heart rate is determined. Because of that, the SA node is heavily innervated by both the sympathetic and the parasympathetic divisions of the autonomic nervous system. The sympathetic, when the sympathetic nervous system stimulates the SA node, we get an increase in heart rate. When the parasympathetic stimulates the SA node, we get a decrease in heart rate. Okay, and we're going to talk about the mechanisms of that in another talk, but those are both true. All right, now the other part of the heart that is innervated heavily is the AV node. Okay, the AV node, its claim to fame is that it delays the contraction signal enough for the atria to contract before the ventricles contract. It's a timing issue. More on that in a minute. All right, so we get same thing, sympathetic and parasympathetic innervation. Then you'll also see in this picture that the whole heart is innervated by the sympathetic nervous system, and that's true. So one of the sympathetic system can also change not just heart rate, but it can change what we call contractility. In other words, how vigorously the heart contracts. Okay, so under sympathetic nervous system stimulation, the heart not only beats faster, but it beats with more energy. In other words, the end systolic volume gets lower because the heart is squeezed extra, right? So ESV goes down, that raises stroke volume. And we'll talk about that more in context when we start putting the regulatory pieces together. Remember, we're kind of doing the physics today. All right, so proof, we just talked about autonomic, and I talked about how sympathetic and parasympathetic are both on all the time, right? And so what we see is a balance. This is a graph of the heart proving that. Okay, so right atrial pressure along the bottom, cardiac output along the y-axis. Okay, so under maximum sympathetic stimulation, we get a big cardiac output, right, for a given right atrial pressure. Now, right atrial pressure is a sort of stand-in for how full the heart is for EDV. When EDV is high, right atrial pressure is high. When EDV is low, right atrial pressure is low. So you could also label this end diastolic volume. As the end diastolic volume goes up, cardiac output increases. But the curves are different depending on how active the sympathetic and parasympathetic nervous branches are, how active they are. The whole point of this graph is to show you the balance, right? That what we see at any given time, okay, is actually the balance between parasympathetic and sympathetic stimulation, right? So we can go up or down. We can increase our cardiac output under sympathetic. We can decrease it under parasympathetic at any given time. So it's not like these two systems are on or off. They're both on. It's just what is the balance, one versus the other.